Alrighty, well, I am truly burning the midnight oil. Just wanted to talk about my progression with robotic-related sewing. Now, it's not the next wave, as I keep saying, it's the bloody only wave, really speaking. I have had an interesting night. Someone's having a hell of a bloody party nearby, I think. Put it like that. It was very hot. Finished doing the table today. You'll see that if you haven't already. Then I decided, since it was so hot and it was still fairly hot inside here, it got up, honestly it was like 95 Fahrenheit or something. And of course this room was still fairly warm, so I thought I'll sleep out in the shack. And I thought I'd take my tablet out there, and I took my tablet out there, and you know, we looked at stuff, and these goddamn bloody 4G modems. Oh man. Well, you know, I must have had it in the right spot, and this thing is as slow as fucking slow as slow. And I should have. And if I wasn't so enthused, I would have just given up and gone to sleep. And then I realised with all this doof going on, I'm not going to sleep out there and not without earplugs. And I can still hear it a little bit inside this house. And it started to get quite cool out there. And then I thought, no point staying out here with doof and it getting colder. So I come inside. So I done that. Turned the modem off, put it in its normal spot, turned it back on. Bingo! The fucking thing was about 10 times the speed, maybe 12 times the speed. And you sit there thinking, shit. So I spent like 3.5 hours going real slow, and I could have just put the modem in here and it would have been fucking fine. Oh, the shit that happens with them things. It's annoying. You got to find your spots. And sometimes, you know, some nights these same spots are good and other nights these same spots are shit, and there's a lot of spots that consistently work or consistently don't work. And I don't know why it was so bloody annoying, because I've had it other nights out there and I think it's been, well, actually it mightn't have been that great out there before. But anyway, I was looking into microcontrollers, which a microprocessor is more close to like a Raspberry Pi. It's more or less a full bloody computer, whereas a microcontroller is really the difference between a microprocessor is microprocessor does a lot of processing. It's got a lot of brains, but doesn't really have very high voltages to drive anything with its inputs and outputs, whereas a microcontroller is quite stupid, but it has a decent amount of volts coming out so that you can at least run LEDs and little friggin', you know, LED number displays and maybe a little piezo speaker like you have in those birthday cards and stuff. And you know what I mean, the tacky little blimmin' buzzers and things that you have, and you know, LCD screens and, you know, things like that. A little bit more oomph, but not as much brain. And if you have a, I think it's an FET, I'm reading now, it's an FET transistor. I heard a lot of these things back in the day, you know, when I was more into electronics and shit, and was a bit of a nerd. But your FET transistor you use, you know, it effectively becomes a relay, so you can basically just boost up the signals that are coming out of your microcontroller to be able to run motors and shit like that. And I was looking at Arduino, and I've seen a few things on Arduino, and, well, you know, you add this board and you add that board and blah, 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 and, you know, and you're looking at this friggin' chips that they got on these damn things, and you're sitting there going, holy shit, this is a fairly complex device with a lot of surface mount devices on it. You know, it's like, the circuit board has chips with fucking pins all over the damn place, like serious amount of pins. And surface mount devices, and it's more like looking at the circuit board of a frickin' 286 computer, honest to God. I mean, it's that fucking complicated. You know, maybe not quite as, well, honestly, it wouldn't be too far off from my memory of my experiences in the 90s. Yeah, it probably would be, nearing a 286 in brains, and probably outrunning in the old XTs in brains. Sort of looking at it going, like, oh, you want to run a speaker? Well, you need this other circuit board, and there's a whole, fucking another dozen components on it, and then this pissy little speaker, and you're just thinking, well, we can just plug this into that, and oh, fuck. I learnt basic using Quick Basic and stuff like that. But I never learned C, and Arduino uses C. And while it doesn't look very complicated, with the amount of shit you need to run a fucking little speaker and all this sort of stuff, like, I'm just used to stuff that's not quite as full-blown to run minor devices. Stuff that's more simpler. And I remember once upon a time reading up quite a bit. Never used one, but I read up quite a bit on a pickaxe. Now, I didn't know if these are still available. And the main place I go to, they're not available. Lo and behold, there's another electronics store that's got like 8 stores around the country. Never fucking heard of them. Several in New South Wales called Altronics. They stock them all. They have pickaxes. You can't even get a fucking book on pickaxe from the usual place I go to. They've got enough Arduino shit to drown you, but nothing pickaxe. And I remember reading about pickaxe, and I was fairly interested because I already knew the programming language, and it's only a very slight couple of extra commands or slight modifications on this thing, because it's not just used for doing stuff on a computer. It's actually used for driving things, and it has inputs and it has outputs, and the best one of all has like 40 inputs and outputs. Can you fucking believe it? I couldn't. They've also got a flash memory. So some of the old ones, it used to be you write the software once and that's it, you're stuck with it, unless you get some fandangle to unprogram it, or they used to use ultraviolet lights and sit it under there for fucking a few hours or something, and it'd clear the memory. And then you rewrite it, but you need to put a little sticker over the top of the little window. You might remember the microchips with a little window, and you could see like the little glass thing, and there's a little chip in there. Like in the middle of your black duva with your legs, you had the little glass thing, you could see the chip in there. A lot of BIOS chips for old computers were like that. And they put a sticker over the top of it to block it from getting much UV light, but it was already inside a computer casing anyway. And back in those days, you didn't have clear-sided computer casings. They were just solid, and they were all beige, and they all looked as boring as shit, basically. They weren't a device for beauty. They were a device for working at a shockingly slow speed. And very, blocky letters and all that sort of. Yeah, a lot of people are a bit funny about MS-DOS. I grew up on MS-DOS. Anyway, getting back to the point, forget what I was saying now. Yes, the pickaxes were made for real input and output things, and you've got one with, up to 40. I think 16 was the highest amount when I was reading it in the late 90s, early 1000s, because they first brought out in 1999. And, you might... It's like this, with Arduino, it's 15 times more high-tech and 15 times the bloody complication of pickaxe. Pickaxe is, getting back to the point, It's got a flash memory, which is just like like the memory in your USB discs, in your SD cards. It's just, you don't need to have constant power to maintain it as you did with some of the old memories. It's not a RAM, it's just like a USB stick or an SD card. And it doesn't need any fancy way to delete it like some of the older microprocessors did. So you can write your program and it goes on your chip. And it's really based on inputs and outputs, and you can tell it to put this LED on, do this, do that. If this input is this, do that. If it's that, do this. And, it's got the ability to really, measure analog to digital, so you can have might be a certain amount of current or whatever come in, and you can say to it, well, if it's this amount, then do this. If it's that amount, do that. There's one where you can hook a temperature sensor on, and the temperature sensor, is controlled by numbers, and you just say, okay, if the temperature's 20, then it's this. If it's 150, then it's that, blah, blah, blah. Or you can actually get a temperature sensor and bring it in and say, this is the input coming from the temperature sensor. Write the input with the symbol for degrees Celsius behind what it is, and it spits it out, and each line gives you a different number, so one input's got your, no, hang on, this is to the screen. One output has, one letter or some fucking thing anyway. I was reading it a few minutes ago, but but anyway, the long and short of it is it's got a lot of analog inputs that can be, sussed out if it's between this and that and that and that, and then spat out as a reading, or if it's below this amount, then put power into this input. If it's above that amount, then put it in the other one. If something's too high, you can put power to lower it. If something's too low, you can put power to make it higher. And do all these sort of bizarre and interesting little things. But the most interesting thing of all is the way that it runs servo motors. Now, I got a bunch of stepper motors, and it explained how you got to, pulse at a certain time. And I'm thinking, yeah, if I deal with these stepper motors, are they going to go slow as fuck on me or what? Because I don't know how fast these stepper motors run, and if I've got to pulse it for a certain amount of time, and I'm sort of looking at the design I'm thinking of, and yeah, these stepper motors are just going to be too slow to run a worm gear, because they move, 7.5 degrees every time you pulse power into them. Out of 360, you add that to a worm gear, you're waiting forever. And so it turns out there's servo motors, and the servo motor it's got like a positive and negative power input, and then you've got another one which you can pulse from 75 milliseconds, and a lot of the time in their programming they actually use 80 milliseconds, through to 200 milliseconds, or is it 250? No, it's 200 milliseconds. And depending on the length of the last pulse you put through this input, depends exactly on where the servo wants to put itself. So if you want it right at the top, you say 80. You want it right at the bottom, you say 200. You want it to move into the middle, you say whatever you want to fucking make a move at. And, between a few FET transistors and bits and pieces, you can make it drive this motor. And, if you really got something else on another circuit that's really large, well, you just put in a relay after this FET transistor. You can do some quite interesting things. Now, these damn chips, by the way, they're only about frickin' $10 or something anyway. And you got this other lead. They used to be serial, like your old style mouse plug. Now they have USB, and you have basically just a little earphone plug, like your little 3.5mm ones that you to listen to your music on your Android tablet or your Android phone on one end and a USB plug on the other. And they've got a little circuit board built into the USB plug end. And it, you know, you just download this freeware program away in this, you know, freeware program, plug, bang, compile and transfer. There's a little bit, you just click this button, compile and transfer, woof, whole lot just goes over to this microprocessor and you're ready to run. And the thing will run between, I think it's 1.6 or 1.8 for some of them. I think it's 1.8 and 5.5 volts. And what a lot of people do is they just get 3 AA batteries and you've got 4.5 volts. What I'm thinking of doing if I do it on the long term, I've seen inside some of these bloomin' USB battery banks. I got one the other day, $15, and I think it's a fucking heap of shit because it didn't want to charge up anywhere near as fast as it was supposed to. I couldn't. You're supposed to charge within 6 hours. It took me more than one night to bloody charge the damn thing. You know what these are. This one's a solar-powered one. It's a heap of shit. But inside these, you usually have a lithium ion if it's a good one, lithium polymer if it's a cheap shit one, battery that's 3.7 volts. So I don't know what they do. It might be some sort of a little transistory thingy or whatever to raise it to 5 volts for your USB plug. A lot of these chips you've got to have a perfect smooth power. You can't have some frickin', you know, one of those cheap shit buzzing fucking AC conversion transformers without having you need a real smooth power supply. And I've seen one of those open, the purple one, which I'm fucked if I know where I've put it, but I've seen one of those open, obviously, and most of them, and including another smashed bloomin' LED light thing I found, they have 3.7 volt batteries. Now, I would not be too worried about just soldering a couple of leads direct to the inside of one of them and using that to power the robotics circuit all day, get to the end of the day or whatever, and just bang it in the frickin' cigarette lighter USB charger through its normal USB plug, just the same way that I am, you know what it is. It's another car charger. I'm just charging the tablet right now, and just whack this, you know, back into, or another one of these battery banks back in and charge it up. But then to make sure the power's perfectly smooth, just draw it straight at 3.7 volts off the battery internally. That wouldn't be a problem at all. And you could run the damn thing. Honestly, the way these things go, you could probably run the bastard for more than a week, maybe 9 days straight, off one of those USB batteries. Getting to what I've found with robotics, I'm not so worried now about a stitch counting mechanism, although the pickaxe would do absolutely beautiful and even tell you how many, and you know, it'd switch everything on and off, and you know, you could easily tell the pickaxe wait and see. I mean, they got all sorts of sensors. You got, you know, heaps of infrared sensors. You got everything you could think of, light dependent resistors, temperature sensors, the whole lot you can whack onto these things. And it's simple as, you don't go and get a board that does this and then plug it into the Arduino, blah, blah. With a pickaxe, you literally solder the frickin' one lead of the device straight to the damn pin of the chip. And I mean, obviously, you're going to have your sensor here and your chip's going to be a couple of foot away. That's all it is. You know, you just literally have the chip in the circuit, and you know, you've got the breadboard, which is like your little, those of you who haven't seen them, it's like a shitty circuit board with all these lines going one way, and you know, just like continuous straight lines side to side. So you can put a chip in and you can solder it to the board, and then you can you know, just whack a bloomin' wire in the end of the board at the right point and attach that to your input. And often enough you need to use a, you know, a positive and a negative to run the sensor, and then you've just got one input wire, and the input wire will just go straight onto the chip. No fucking extra circuit you got to plug in, no fucking, oh, well, this is a sensor for ultrasonics, so you've got to plug it in and then you've got to software. No fucking way. You just get the damn sensor, you just solder a wire to it, and then a wire to the circuit board which just goes straight to the pin. That's often the case, and every time you got to step it up, all you got to do is add one of these FET transistors. It's very simple. Whereas Arduino is for people who are too scared to use a fucking soldering iron, Pickaxe is for people who just want to get on with the fucking job and make the circuitry very simple and the programming very simple and everything extremely direct. And you could use a light-dependent resistor or infrared sensors or some little friggin' bullshit switch or whatever, and the Arduino would quite happily count the amount of stitches. In fact, you could even get it to write it on its little LCD screen, which you can attach to it to tell you how many stitches are there. Or it can just run along and then say, okay, you know, wait for this amount of stitches. When you've reached this number of stitches, then, you know, turn off output blah blah. So that turns off that output, which turns off the FET transistor, which turns off the relay, which cuts out the engine of the sewing machine. And then put this light on to say, you know, green LED, we're waiting for you to move the cloth. So then you lift the foot up, you turn the cloth around, you put the foot back down, and then you press the go button. Bang, engine back on again, count another amount of stitches, bang, stop again. It would do that absolutely fantastically, brilliantly, you know, and it'd be so shockingly easy to program and so shockingly easy to wire up, just so long as you got this bullshit right with cutting the fucking engine on and off, which a mate of mine will help me with, hopefully. You'll be right. But I have also been buggerising around on YouTube watching other robotics. Now, all the robots that I've seen so far in the place that's called Software, SOFTWEAR, which is a big startup in America that's supposed to be making a factory that does 1 million shirts a year or 500,000 a year, completely robotic, and they're going to open it in 2018, so they claim. A lot of their gear and other people's gear runs off of these things. Now, just make sure you can see this little bugger. This one's a bit more extensive than some of them. There's your short shank attachment. That little piece you can see between me thumb and me middle finger is where you know, attach it to the machine. In the back here, we have a coil spring, and she goes boing, boing. This here, generally speaking, in most of them, is an arm, and they've just used a bit of wire. What this is, well, a fairly old-style darning foot, and a lot of them don't look quite this big, and a lot of them have a bit of a better arm, but they all have this signature bloomin' look of this ring, and this one goes side-on. Most of them, like the arm that holds onto the ring is side-on, to the right there. Most of them, they go straight backwards with it. But a lot of these, this is basically what they call a darning foot, sometimes called a quilting foot. Well, this is an intriguing little foot because this is a foot where, to use it properly, there's another one that looks like a fucked up clear biro, like a pen with a spring inside it, like an actual coil spring, and this little flat plastic bit on the bottom, and that's a modern one. I don't trust them. They look like they're going to snap at any minute. But what these are, like most machines and most feet, whether you're using a roller foot or a standard foot or a frickin' whatever, I've found I've even got a zipper attaching foot in there and another foot that I don't know what the frickin' hell it's used for. What happens is with these, lost my train of thought. With these feet, usually you've got feed dogs, which are your little prongs, which I do have some blowing around. Come with that other bizarre thing. And your little prongs, oh, you might as well look at this, are under there. And those little prongs pull your fabric through. And they pull it through and it slides under whatever foot that you got on at the time. But what you do is you disengage those, and in fact, there's that white button right there. That will disengage them. With the other machine, I've got another. You can't see very well, but there's a white knob you flick that's actually down lower on the machine. So usually about the last knob you got on the machine in general will be the one that disengages your feed dogs, so they stop feeding. And at that point, the robot pulls it through. The servo motors, the linear actuators, some sort of motor, some sort of arm, some sort of thing will pull it through, because you disengage those feed dogs. They no longer move, they drop down low into the machine. A handful of cases they've got to put covers over them, but that's not very many machines at all. You do that. Most of them you just got to flick some knob or some button and clonk. You cycle once and just cycle the needle up and down once and you'll see the feed dogs drop right down. And how this little sod works is that ring I was showing, every time the needle goes in, the ring will hit the bottom and hold the fabric for a split second while the needle goes in and comes out, and as the needle comes out, boom, up it goes. And the little screw that holds the needle in place has a little sheath around where that screw goes in, and this little arm, this bit of wire, which is usually an arm, is hit by that screw sheath to force it to hold down while the needle goes through the fabric and comes back up, and as it comes back up, the little sheath is out of the way, and then the spring will just allow this to jump up. And this might be a reverse one where it's actually not pushing the back of it, it's actually pushing the front of it. And it's not touching it as it's down, so it spring holds it down, and then as it comes up, it grabs that top little curl there, and then, lifts it out of the way. I'm not too certain, I haven't put it on yet. But that's basically the way it works. And so you give away your feed dogs and any stitch counting involved in those feed dogs. And, make the robot or the servo motor or the linear actuators or the hydraulics or the like air hydraulics, or whatever you're using, move the fabric. And this thing will allow you, generally speaking, to move the fabric around by hand, and it will just hold the fabric temporarily as the needle goes in and out of it, to allow you to draw flowers, write your damn name, do any bloody thing you want to do on a piece of fabric. So that's the way they do it all. That's the way they run. They run with one of these feet and then just have a robot move the damn fabric wherever they've programmed it to move it. And that generally is how most people experimenting with robotics go ahead and do it. And with me, I think it'll be basically a bit like the Portuguese first generation. Well, I'm not saying the Portuguese system, but they're using them in Portugal, I know that for a fact. And, Juki in Europe in general, they show similar sort of systems that they have. And basically it's like a frame, and you basically pull the fabric over the frame just like you pull the skin of a drum over the drum frame, and you clamp it in place. And you know, in the case of a lot of these ones, it's actually just 2 bits of sheet metal that looks like stainless steel, could be aluminium, and they just, you know, jam the fabric in, bang, close the 2 bits of sheet metal together, and it must have some little clip or something to hold the side of it, and then boom, off it goes. And the machine will generally, I can't remember if the machine moves or the template moves, but in this case, you could, you know, attach the frame, could drop into a secondary frame that is moved around by servo motors. And this pickaxe controller, it has a command where you say pause, and then you write how many milliseconds you want it to pause for. So what you can actually do is ask it to move the, you know, you'd have it on some sort of a loop to go from 80 to 200 and make it move, you know, jump at 10 every time, or maybe only make it move individually, and each time you have a 50 millisecond pause or 100 millisecond pause or something between each movement, which means that it won't go too fast for the, you know, sewing machine to actually sew it. And all you're basically going to have is like the outside of a picture frame holding another outside of a picture frame that is clamping down the cloth, and then it just, you know, you press the go button and it just starts moving it around and it just starts sewing it. And that's basically how you would go ahead and make just simplified robotics. And I'm not saying you can always get it to work spot on, but you can get very simple shirts and certain things that mightn't be the most perfect fit, you know, just straightforward basic stuff, and get it to do, you know, half of the process, or in things such as crappy bags that people carry around for shopping these days because they're scared of plastic bags or whatever it is, save the environment, you know, or cheap cloth aprons, you know, a lot of those things you could just get the machine to do friggin' 90% of it, you know, or everything except the straps, and then you leave the straps to a second machine, or you just do those yourself or whatever. But, you know, things like long hems and bits and pieces and edgings and all that, you know, you could set the machine just to do it with this little bloody $10 chip controlling a couple of servo motors with a couple of FET transistors and a couple of LEDs telling you yes, no, and one relay to turn the motor of the sewing machine on and off, and you've done it. And that's it. So anyway, I know I repeated myself a couple of times there, but you get the general idea, and yeah, there's probably fuck all people watching by the time I get to the end of this.